Welcome to Cambridge IGCSE Physics, Lesson 31.1, Regions of the Electromagnetic Spectrum. Today we explore the complete electromagnetic spectrum, from radio waves to gamma rays, understanding their order by frequency and wavelength. Let's examine our learning objectives for today. By the end of this lesson, you will be able to know the main regions of electromagnetic spectrum. These are radio, microwave, infrared, visible, ultraviolet, X-ray, and gamma. Know the order by frequency, from lowest to highest frequency. Know the order by wavelength, from longest to shortest wavelength. These objectives align with Assessment Objective 1, Knowledge, and Assessment Objective 2, Application. Now let's define our key vocabulary. Each term is essential for understanding this lesson. First, electromagnetic spectrum, which means the complete range of electromagnetic radiation from radio waves to gamma rays. Second, radio waves, which means the lowest frequency electromagnetic radiation with longest wavelengths. Third, gamma rays, which means the highest frequency electromagnetic radiation with shortest wavelengths. Understanding these terms precisely is crucial for exam success. Let's explore the complete electromagnetic spectrum. The fundamental principle states that all electromagnetic radiation travels at the speed of light in vacuum. There are 7 main regions, each with distinct properties. The order by increasing frequency is radio waves, microwave, infrared, visible light, ultraviolet, X-ray, and gamma rays. Mathematically, we express the relationship as C equals F lambda, where C represents the speed of light at 3.0. times 10 to the power 8 meters per second, F represents frequency measured in hertz, and lambda represents wavelength measured in meters. The diagram illustrates how frequency increases from left to right, while wavelength decreases. Notice the inverse relationship between frequency and wavelength. Now we examine the relationship between frequency and wavelength. This follows the fundamental wave equation. The key relationship is that frequency and wavelength are inversely proportional. This means when one increases, the other decreases. Gamma rays have the highest frequency and therefore the shortest wavelength. Radio waves have the lowest frequency and therefore the longest wavelength. Visible light sits in the middle of the spectrum range. The diagram shows this inverse relationship clearly. Notice how the frequency arrow points right indicating increase, while the wavelength arrow points left indicating decrease as we move across the spectrum. Let's work through our first example. The problem states, calculate the wavelength of radio waves with frequency 1.0 times 10 to the power 6 Hz. We are given frequency equals 1.0 times 10 to the power 6 Hz and speed of light equals 3.0 times 10 to the power 8 meters per second. We need to find the wavelength lambda. Step 1. Write the equation. We use the wave equation, which is C equals F lambda. Step 2. Rearrange for lambda. Lambda equals C divided by F. Step 3. Substitute the values. Lambda equals 3.0 times 10 to the power 8 meters per second divided by 1.0 times 10 to the power 6 Hz. Step 4. Calculate. Lambda equals 300 meters to 3 significant figures. Example 2 applies the same principle differently. The problem is, find the frequency of X-rays with wavelength 1.0 times 10 to the power minus 10 meters. The data shows a very short wavelength, which indicates high-frequency radiation. Now we analyze. First, use the wave equation C equals F lambda. Second, rearrange to find frequency, F equals C divided by lambda. Third, substitute values. F equals 3.0 times 10 to the power 8 divided by 1.0 times 10 to the power minus 10. Fourth, calculate the result. F equals 3.0 times 10 to the power 18 Hz. The diagram shows X-rays position on the spectrum, confirming this is high-frequency, short wavelength radiation. Mathematical skills are crucial in electromagnetic spectrum calculations. Let's examine 3 key skills. First, scientific notation. Large and small numbers require standard form. Radio wavelengths like 300 meters become 3.0 times 10 to the power 2 meters. Gamma wavelengths like 0.000000000001 meters become 1.0 times 10 to the power minus 12 meters. Second, unit conversion. Frequency units, 1 megahertz equals 1.0 times 10 to the power 6 hertz. Wavelength units. 1 nanometer equals 1.0 times 10 to the power minus 9 meters. Third, order of magnitude comparisons help understand the vast range of electromagnetic radiation using powers of 10. Now practice what you've learned with these 3 questions. Question 1 is basic level. It asks, list the electromagnetic spectrum regions in order of increasing frequency. This tests your knowledge of the 7 main regions. Question 2 is intermediate. It states, calculate the wavelength of microwaves with frequency 2.4 times 10 to the power 9 Hz. This requires you to apply the wave equation we've learned. Question 3 is advanced. The question is, compare gamma ray and radio wave wavelengths using scientific notation. This tests your analytical skills and understanding of orders of magnitude. For all questions, remember to show you're working clearly, include units in every step, and check your answers make physical sense. Physics principles power our modern world. Let's see how electromagnetic spectrum knowledge applies in practice. In communications, radio waves carry AM and FM broadcasts, while microwaves enable mobile phone networks and satellite communications. The specific frequencies are chosen based on propagation properties and atmospheric absorption. In medicine, X-rays provide internal body imaging because they penetrate soft tissue but are absorbed by bones. Gamma rays treat cancer by targeting tumor cells with precise high-energy radiation. In astronomy, different spectrum regions reveal different cosmic phenomena. Radio telescopes detect pulsars, infrared shows star formation, visible light reveals stellar properties, and gamma rays indicate violent cosmic events. Career-wise, telecommunications engineers design transmission systems, medical physicists operate imaging equipment, and radio astronomers study cosmic radiation. Let's review the solutions. For question 1, the correct order of increasing frequency is radio, microwave, infrared, visible, ultraviolet, X-ray, gamma. Remember this sequence. It's fundamental knowledge. For question 2, we use lambda equals c divided by f. Substituting, lambda equals 3.0 times 10 to the power 8 meters per second divided by 2.4 times 10 to the power 9 hertz, giving 0.125 meters or 12.5 centimeters, typical microwave oven frequency. For question 3, gamma rays have wavelengths around 10 to the power minus 12 meters, while radio waves have wavelengths around 10 to the power 3 meters. That's 15 orders of magnitude difference, showing the spectrum's vast range. Exam success tips. Learn the spectrum order using memory aids like radio mice in visible underwear. Examine galaxies. Always show you're working with equation, substitution, and final answer. Check units are correct throughout. Use scientific notation for very large or small numbers. Let's summarize today's lesson. The key points to remember are, first, there are 7 main regions of the electromagnetic spectrum arranged in order of increasing frequency: radio, microwave, infrared, visible, ultraviolet, X-ray, and gamma. This sequence is fundamental and must be memorized. Second, the wave equation C equals F lambda links the speed of light, frequency, and wavelength. This equation allows calculations throughout the spectrum. Third, frequency and wavelength have an inverse relationship. High-frequency radiation like gamma rays has very short wavelengths, while low-frequency radiation like radio waves has very long wavelengths. For further study, practice spectrum ordering until automatic. Solve multiple wave equation problems to build confidence. The next lesson covers uses of electromagnetic radiation, which builds on today's foundation by exploring practical applications of each spectrum region. Master today's concepts before progressing.